Here's our lesson on 8.4, solve problems using trigonometry. This is actually the last lesson in our trigonometry unit. So you're going to have an assignment after this, and then we will have a little test. So we need to figure out what to use when. We've learned a lot of stuff. We did know Pythagorean theorem from before, but now we know how to solve sides and angles using trig ratios. We know the sine law and we know the cosine law. So we need to figure out what to use when. There is a little chart here in the note. If you do have the blank copy of the note, it's a little clearer on there. However, there it is there. So when do you use the trig ratios? Sohcahtoa. When is the only time you're going to use the trig ratios? That is when you have a right triangle. So a triangle that's going to have 90 degrees. That's when you use Sohcahtoa. These are called your trig ratios. So you have 90 degrees. When do I use the sine law? So sine law is used in acute triangles. So all the angles are less than 90. Acute triangles. And you're either given two sides and an angle opposite. So given two sides and an opposite angle, which would give you your opposite pair. Or given two angles, that means you can find the third really easily by taking 180, subtracting the 2. So given two angles and any side, that will also lead you to being able to have an opposite pair. When do you use cosine law? Again, in acute triangles. So when all the angles are less than 90, and you're either given two of the sides and the contained angle, so that would be the angle in between the two sides. So two sides and contained angle, or all three sides. Okay, so in the little chart here, it just shows you that if you have two sides and an angle, you can use sine law. Two angles and a side, you use sine law. Two sides in the contained angle, so the angle in between, you use cosine law, and all three sides, you use cosine law. So we're not going to solve these. We're just going to state which formula we would use to solve for the unknown. So we're not actually going to go through and solve them. We're just going to try to pick out what formula we would use. So if I want to solve for side y, the first thing I would look for is to see if it's a right triangle. Then I would use trig ratios. Unfortunately, it's not. So then I got to pick between sine law and cosine law. Because I see that I have these two sides with the angle in between, that screams to me cos law. So two sides and the contained angle is cos law. So if I was going to use cos law with this to solve for that little y, I would be doing y squared equals the other two sides. So we have x and z, so x squared plus z squared minus 2 times the other two sides, x and z, cos of the angle opposite the side. So I just want to make sure that first y looks like a little y. I kind of made it look like a big y, little y. So that would be the cosine formula that I would use to solve for little y. All right, let's move on to the next one. We're trying to find angle B in this triangle. It's not a right triangle because I don't see that little 90-degree sign. And I do not have a side angle pair because you're actually not given any of the angles. So this, again, you're given all three sides. This is cos law again. Cos law. But this time I'm solving for angle B. So we are always going to start with the angle, which is cos B equals a squared plus c squared minus b squared all over 2ac. And third triangle, I see my right angle, so I know this is going to be trig ratios, which is Sohcahtoa. So if I'm trying to find this angle here, this would be my opposite. This would be my adjacent. So I'm going to be using the tan ratio. O and A is the tan ratio to solve for that angle there. All right, so we're trying to find little a here. So right away I see that I have an opposite pair, a side angle pair. So this means I'm going to be using sine law. And I'm trying to find little a, so I'm going to be using the one that starts with the little a on top just because it's easier to solve for. And then my side angle pair is my b's. So little a over sine a equals little b over sine b. And the next one, again, it looks like I have a side angle pair, but I don't. I have actually two sides and the angle in between. So this is Cos Law. And I'm solving for little d, so I'm going to start with d squared equals the other two sides, which we got e and f, minus 2 times the other two sides, cos of the opposite angle. Solving for angle Q, I see that right angle there, so I'm going to use the trig ratios, or Sohcahtoa. I have, let's see, this is the angle I'm looking for, so I have the hypotenuse and the adjacent, so A and H. So that is going to be the cos ratio, A and H. And at the bottom here, again, I see a right angle, so I know I'm going to be using trig ratios again. But which trig ratio am I going to use? We're looking from this angle, so I have my opposite. And I'm trying to find side P, which is my hypotenuse. So O and H, if we think of Sohcahtoa, that would be our sine ratio. And next one, again, I'm looking for an opposite pair if it's sine law, which I see is right here. So because I don't see the right angle, I automatically ruled out Sohcahtoa. I ruled out trig ratios and I moved on to sine law and cos law. I see my opposite pair, so I will be using sine law. So I'm trying to find angle C, so I'm going to use the sine law that starts with the angle on the top, so sine C, and then your angle pair. So I'm using the B's as my other ratio. And last one, this almost looks like a right triangle, but it's 88 degrees instead of 90, so I can't use trig ratios. But again, I have that opposite pair, and I'm trying to find little m, which means I would need big M in order to use sine law, but you can find that because you could take 180, subtract these two. So 180 minus 88 minus 58. So I could use sine law. I just have to do a little step in between. So to find little m, we would start with that over sine m. And then our opposite pairs are k's. So little k over sine k. All right, now let's actually solve some problems here. You are going to have some directional problems. They are going to maybe tell you that something's east or west, and there's something that maybe you haven't seen. So this is when it's something like S 30 degrees west, you would actually draw a vertical line south and then turn it 30 degrees towards the west. The west is over here, so 30 degrees. So S 30 degrees west would be this angle here. So you draw a line south and then it'd be 30 degrees west. So that's just kind of an aside. They may throw something like that at you, which the next question does. So a boat leaves Toronto, heads due west for 8 kilometers. So we're going to start off here labeling our triangle here. This is Toronto. And I knew that because due west would be this way here. Due west for 8 kilometers. So let's label that 8 kilometers. At the same time, a second boat travels in a direction N 40 degrees west. So again, N is north, so you draw a dotted line north, and it's 40 degrees to the west, which the west would be to the left. So this in here is 40. For 3 kilometers. So this is 3 kilometers. I get a little messy here. How far apart are the boars, I'm going to guess that's boats, when they reach their respective destinations? So what we're actually trying to find is this value here. Now let's label our triangle. we can have A, B, C. So we're trying to find little c. We're trying to find that distance there. So find little c. That's our goal. This would be little a, little b. All right, so we have two sides. We would almost have our angle in between, don't we? We have that this one is 40, and I know this is 90 degrees. So this angle in here is actually going to be 180, not 180, 90. 90 subtract 40 because they're complementary, which means this angle in here is 50. So now I have two sides in a contained angle. That tells me that I'm going to be using Cos Law. So two sides in a contained angle is Cos Law. And I'm trying to find little c, so I'm going to be using Cos Law that starts with little c. So let's try to work this out here. C squared equals the square of the other two sides minus 2 times the other two sides, cos of the opposite angle. So that's cos c. And we're going to try to fill everything in that we know. So little a is 8. Little b is 3. AB then is obviously going to be 8 and 3. And cos of angle C, we figured that out, was 50. So again, I like to just type in my calculator 8 squared plus 3 squared. That gives me 73. And then negative 2 times 8 times 3 times cos 50 would give me negative 30.8538. If I subtract those in my calculator, notice I'm keeping a bunch of decimals here. That's just for accuracy so that my answer is as accurate as possible. And because I want c, not c squared, we're going to take the square root of that, which is going to give me 6.5 approximately. So I rounded that to 1 decimal place because it doesn't tell me. So side lengths are usually rounded to 1 decimal place. So therefore, let's answer the question, how far apart are the boats? So therefore, the boats are 6.5 kilometers apart. Allie's trying to hit her golf ball between two trees. She estimates the distances shown in the diagram. Within what angle must Allie make her shot in order to pass between the trees? So this one is actually looking for angle A. Round the angle to the nearest degree. Okay, so it's not a right triangle. Not going to use trig ratios. I do not have any side angle pairs because I'm not actually given any of the angles. So that leaves us with Cos Law, which makes sense because we're given all three sides. So if I'm trying to find angle A, I'm just going to go ahead and label the other two sides, B and C. Little b would be across from big B, little a, and little c. So always make sure you got the diagram and the angles and sides labeled correctly. I'm trying to find A, so I'm going to use the Cos Law formula that starts with capital A. So that is b squared plus c squared minus a squared all over 2bc. And again, you don't have to memorize that. You might just have to look back in your notes to find the formula. We're going to substitute everything that we know. We have 49 squared plus 52 squared minus 75 squared all over 2 times 49 times 52. And I'm going to go ahead and calculate the top out, which gives me negative 520. And the bottom is going to be 5,096. That's okay that you have a negative. Because I'm solving for an angle, we always use that inverse. And I'm going to plug that into my calculator and round it. It's going to be 96 degrees. So therefore, she must make her shot within 96 degrees. And I can see there, because you did end up with a negative, we ended up with an angle bigger than 90, which is not an acute triangle. However, you still do use Cos Law. You normally don't see that until grade 11, but still works. So in the textbook, you probably would not end up with a negative in there. The base of a sail is 14 meters wide. The angle of elevation on the right side is 45 and on the left is 55. Let's draw a picture. So a sail like on a sailboat. We have the angle of elevation. Don't forget that that word means from the horizontal looking up. So on one side it's going to be 45 and on the other side it's 55. So there's a picture of our sail. It's 14 meters wide. So let's just add that that's 14 meters wide. And we want to find the lengths of the other two sides. So I'm just going to go ahead and label my triangle here. We have A, B, and C. Little a, little b, little c. So our job is to find little b and little c. What are the lengths of the other two sides? All right, so let's find little b. In order to find this, we are going to have to, well, we can't use Sohcahtoa. It's not 90-degree triangle. Could we use sine law? Do we have a side angle pair? I have two angles and a side. So if you have two angles and a side, you can use sine law. We're just going to have to do a little bit of work here to find our opposite pair. Because I'm given the side is 14, I really want this angle in here. So angle A is going to be 180, subtract 55 and 45. That's going to give me an angle of 80 degrees. So this is 80. Now I have my side angle pair. I can see that I have both of the A's. If I want to find B, I'm going to start with B. So B over sine B. And my side angle pairs are my A's. And I'm going to sub in everything I know. So B is 55. Little a is 14. And I just figured out that big A is 80. I want B all by itself, so I'm going to take that sine 55 and move it over to the other side. It's going to be multiplied at the top. And if I plug that into my calculator, I don't have to use the inverse because I'm not solving for an angle. I get 11.6 meters. So there's one. Let's go ahead and find the other one. So let's find C now. To find C, I'm going to use C over sine C. And I'm going to use that same angle pair that I used in the first one. So we used the A's. We're going to use the A's again. So big C is 45 degrees. And using that same side angle pair, I'm just going to copy that from the other question. Getting C by itself, I'm going to move that sine 45 over to the other side. And then you're just plugging that into your calculator. You get 10.1 meters. So therefore, what are the two lengths? So therefore, the lengths of the other two sides are 11.6 and 10.1. What is the area of the sail? So if I have this sail here, well, that wasn't a very good drawing. I have the area of the sail and picture of the sail. I want to find the area. Don't forget that the area of a triangle is the base times the height divided by the 2. So I do know the base. The base is 14. The problem is I don't know the height of this triangle. So let's use some of the information from the part A above. So I know, let's use this triangle over here. I know this is 45 degrees. And I figured out that this side over here, that one was side B, so this is 11.6. So because I have those two values, I can go ahead and find the height. Let's call that X. This is a right triangle. So because it's a right triangle, I'm going to use Sohcahtoa. And if I do some labeling here from the 45-degree angle, this would be my opposite and my hypotenuse, so O and H, which means if I look at Sohcahtoa, O and H is sine. I'm going to be using that 45-degree angle as my angle of interest. My opposite is x. My hypotenuse is 11.6. And if I want x all by itself, I'm just going to take that 11.6 and multiply it. So we get 8.2 meters for our height, which means my area is our base times our height divided by 2, which is 57.4 meters squared. So therefore, the area of the sail is 57.4 meters squared. Okay, your homework is listed there. Again, you're probably going to have some questions, maybe just some difficulty drawing a diagram or anything like that. Feel free to email me and I will help you out. I can draw a picture of the diagram and email it back, or help you out in any way I can. So we will take some of these questions up at the next meeting. And again, just email me if you need anything.